Hello everyone, my name is Elena Magallanes and right now I'm in 6th semester of Mechanical Engineering. In this video I'm going to show you how to do the worksheet 7 with the title Parasolid Solid Example. The objective of this workshop is to learn some of the steps that can be used to create a V-Rep solid, extrude, surface, shell, and edge blend. Then create the finite element model, analyze the model, and post-process the result from its analysis. The softwares that we are going to use are Patron and Nastran. Here you can read the problem description. Remember that the first things to do is to create a new folder where you're going to save all your files. First, we're going to create a new database for tension fitting. We're going to click on New, enter tension fitting as the file name, and we're going to save it in the folder that I mentioned before. Then we're going to click OK. Choose based on mother for tolerance and choose MSc Nastran and structural for analysis, code and type. Then click OK. The next step is to create the surface. We're going to click on Geometry and make sure that Create Surface and XYZ are selected. Then we're going to enter 520 for vector coordinates list. And then for the origin coordinate list, we're going to enter 0, 0, 0. Then click Apply. Then we're going to click on Home and we're going to click on Increase Point Size icon to show all the points in large. We're going to Geometry again and we're going to make sure that Transform, Point and Translate are selected. We're going to enter 0.500 for translation vector and select top left corner and click Apply. Remember to turn Auto Execute off. Then we're going to enter 0, 0.50 for translation vector. And we're going to select bottom right corner and click Apply. Then we're going to make sure that Create Curve and Point are selected. Click on one of the 2 points from translation as the starting point and the other as the ending point. Remember to turn Auto Execute off. And then click Apply. Now we're going to break the surface and delete the upper portion of the original surface. We're going to Geometry and make sure that Edit, Surface and Break are selected. Turn Auto Execute off. Then we're going to select the rectangular surface for the surface list and the slope curve for the break curve list. Click Apply and Yes when message box appears. Click the refresh graphic icon. Now we're going to delete the upper surface. Make sure the Delete and Surface are selected in Geometry. Click on the triangular surface for the surface list, and then click Apply. Now we're going to create a Parasolid solid by extruding the surface in the Z direction. Make sure that in Geometry, Create Solid and Extrude are selected. Then make sure that Measurable Solid icon is selected. And then enter 002 for the translation vector. Select the following surface in the surface list box and make sure to put Auto Execute off. Then click Apply. Now we're going to Home and we're going to make a click in ISO 1 view. And then we're going to make a click in the smooth shaded icon. Now we're going to create a shell solid. Make sure that Edit, Solid and Shell are selected in Geometry. Now we're going to enter 0.25 for thickness and turn Auto Execute off. Click on Solid Face List and hold down the Shift button and select the top, slab and front faces of the solid, as shown. Then click Apply. Now we're going to create fillets. Make sure that Edit, Solid and Edge Blend are selected in Geometry. Now make sure that the constant radius icon is selected. And enter 0.25 for constant radius. Make sure Edges of Solid icon is selected and turn Auto Execute off. Click on Solid Edge List and use the Shift Click technique and select the 5 edges on the inside of the solid as shown. Then click Apply. Now we're going to create holes for the tension fitting. Make sure that Create Solid and Primitive are selected in Geometry. Then select the cylinder icon. Enter 2.0 for a height and 0.25 for the radius. In the base center point list, enter -1, 1.25 and 1. Remember to turn Auto Execute off. And enter 0.1 for the axis list. Then click Apply. Now make sure that Edit, Solid and Boolean are selected in Geometry. Now we have to select the Subtract icon. Select the tension fitting for the target solid and remember to turn Auto Execute off. Then select the cylinder for the subtracting solid list. Then click Apply. Now we're going to make a click on the wireframe icon and we're going to make sure that Transform, Point and Translate are selected in Geometry. We're going to enter 0, 0 and -0.5 from Translation Vector. and select point at base edge of fillet. Remember to turn auto execute off. Then we're going to click apply. For translation vector, now we're going to put minus 0.7500. We're going to select the next translating point. And then we're going to click apply. Now for translation vector, we're going to put minus 1.5000. Now we're going to put 2 for repeat count and select the next translate point. Then we're going to click apply. Now we're going to create cylinders using points as base centers and then create holes by subtracting them from the solid. We're going to click smooth shade icon and make sure that create solid and primitive are selected in geometry. Then we're going to select cylinder icon. Enter minus 1.0 for height list and 0.125 for radius list. Use the shift click technique to select the trim translate points for base center point list. Remember to turn auto execute off. Enter chord 0.2 for axis list and then click apply. Now we're going to make sure that edit, solid and boolean are selected in geometry. We're going to select the substrate icon and select tension fitting as target solid. Remember to turn auto execute off. Shift click all 3 cylinders for subtracting solid list. Then we're going to click apply. The next step is to create a cylinder to imprint tension fitting. We're going to click wireframe icon and make sure that create point and arc center are selected in geometry. Then select the larger hole edge. Make sure to turn auto execute off. Then click apply. Now we're going to make sure that create, solid and primitive are selected in geometry. Now we have to select cylinder icon. Enter 1.0 for height list and 0.371 for radius list. Now click on point in the center of the large hole. Make sure to turn auto execute off. And enter chord 0.1 for axis list. Then click apply. Select smooth shaded icon. Now we're going to imprint the solid. We're going to make sure that the edit, solid and imprint are selected in geometry. Now we're going to select the tension fitting for the solid list. Select the cylinder for the solid to imprint list. Make sure to turn auto execute off. Then we click apply. Now we're going to delete the cylinder. Make sure that delete and solid are selected in geometry. Now we're going to select the cylinder for solid list. Make sure the auto execute is off, then click apply. Now we're going to make a click in meshing and make sure that create, mesh and solid are selected. Make sure that mesh and that 10 are all selected. Click on input list and select the solid. Remove check for automatic calculation and enter 0.25 for global edge LED. Now we are going to click apply. This step is to create the TED mesh for the tension fitting. Then we're going to create the loads and constraint for the model. We're going to click smooth shade icon and make a click on load BCS and make sure that create, total load and element uniform are selected. Then we're going to enter force as a new set name and make a click in input data. We're going to enter the next value for the load and click OK. Now we're going to make a click and select application ratio and select the vertical solid face created by the imprinting at the larger hole. Then click add. Click OK and apply. Because we have the student version of the pattern, the software doesn't let us use these values, so we're going to change it to -2000. Now we're going to make sure that create displacement and nodal are selected in loads BCS. We're going to enter fix as new set name and click in input data. For translation, we're going to enter 000 and then we're going to click OK. We're going to make a click and select application ratio and click on select geometry entities. Select surface or face icon. Shift click the cylindrical faces of 3 holes at the base and then click add. We're going to make a click on OK and then apply. Now we're going to create the material properties. We're going to make a click in properties and isotropic. We're going to make sure that create isotropic and manually put are selected. We're going to enter aluminum for material name and click in input properties. Then we're going to enter the following values for elastic modulus and Poisson ratio. Click OK and then apply. Now we're going to make a click in solid to create 3D element properties. We're going to make sure that create 3D and solid are selected. We're going to enter 3D text for property set name and then we're going to make a click in input properties. Click Matte Prop Name icon and select aluminum from select material. Then we're going to click OK. For application ratio, select entire solid by dragging a box around it, and then click Add. Finally, we're going to click in OK and then in Apply. Now we're going to check the load case. We're going to make a click and load BZS and make a click and load cases. We're going to make sure that Modify is selected. Click on the load case name Default. Check to see that both the load and constraints are assigned. Then click Cancel. Then we're going to run the analysis. We're going to make a clicking analysis and make sure that Analyze an entire model and full run are selected. We're going to make a click on Solution type and make sure the linear static is selected. Then we're going to click OK and then Apply. As you can notice, our mesh disappeared, so we're going to try to dead mesh the complete solid again. And now we're going to run the analysis again. Because of the student version that I'm using right now, the software doesn't let me run the analysis. So I'm going to explain to you what you have to do next with some slides. Once you have run your analysis, you have to access the results. You have to attach the XDB file and access the results. You need to click on Analysis, Access Result, Attach XDB, and Results Entities. Click Select Results File, select Tension Fitting.xdb, and click OK. Then click Apply. The next step is to display results. We're going to click on Results and make sure that Create and Deformation are selected. We're going to select SC1 Default A1 Static Soft-Case under Select Result Cases. Then we're going to select Displacement Translation from Select Deformation Result, and then we're going to click Apply. Now we're going to display results and erase the geometry and do not show the undeformed model so that only the deformed model is shown. We're going to click in Display and click on Plot Erase. Click Erase under Geometry, then click OK. Click Display Attributes and remove Check from the Show Undeformed. For the render style, choose Shaded. Then we're going to click Apply. Here is how your model should look. Then we're going to make a click in Results and make sure that Create and Fringe are selected. Then we're going to select Stress Tensor from Select Fringe Results and select Display Attributes. Then set Display to Element Edges. We're going to click Apply next. Here is a note that says, it may also be helpful to change the view several times in order to get a better visualization of the deformation. This can be done either by holding down the middle button of the mouse or using the view icons. Well, this is everything for this video. I really hope you like it. Don't forget to give me some thumbs up and go and check my other videos. Bye.